This video talks about natural language processing. Now, you might not have heard this term very often before, but I'm fairly confident you interact with NLP on a daily basis. You rely on search engines to find out information about a topic you care about. You rely on spelling correctors because who can spell language correctly? And you probably rely on machine translation tools, for example, for accessing information into your native language. Now, maybe since last year, you don't use any of these tools anymore, but rather you prefer to just use a conversational agent, which is a tool that can do all of these things into one single model. Now, you might have heard that these conversational agents are powered by large language models, or LLMs. LLMs are indeed the core building blocks of these conversational agents, and basically the core building blocks of all NLP tools. What are they? They are a neural network that is trained for the task of language modeling. Now, what is the task of language modeling? Imagine you're reading out this sentence to a human. Unicorns bring joy and wonder to everyone they. And then you ask that human to predict what word comes next. This human will very likely tell you meat, or quite likely no or see, but they will very unlikely produce the word the or they. And so the idea is that if we can teach a human to carry out this task, we can also teach a neural network this task. So we train a neural network where the input is the beginning of a sentence, for example, unicorns bring joy to everyone they, and we ask it to predict the next word. And this is obviously an iterative process where it will get it wrong many times before it gets it right. And every time it gets it wrong, you update the weights of the neural network to get slowly closer to the truth. Now, a neural network that can predict next words is not all that useful by itself. But why is it useful? It is because it learns useful vector representation of words in the context in which they occur. These representations are then used in a task that is actually useful. For example, machine translation. So you take your neural network that was trained for predicting upcoming words in text and fine-tune it to carry out the task of machine translation. Here, your input is a sentence in a source language, for example, English, and the output is a sentence in a target language, for example, here, Dutch. Now, how do we do this fine-tuning step? It requires a specific type of dataset. A parallel dataset that contains sentences in English, like what you can see on the slide here, and their corresponding sentences translation into Dutch, like the right side of this slide here. So an LLM is trained on a lot of pre-training data for the task of language modeling, and this has the advantage that for pre-training, you can use basically any type of data. It does not need to be specialized like a parallel corpus. It can be web data, news data, etc. And so this pre-training data is used to pre-train the LLM to learn useful representation of words in the sentences in which they occur. And this LLM is then fine-tuned to perform the task of machine translation. The LLM can also be fine-tuned on other tasks, such as spelling correction. And for this, you also need a specific type of dataset, Here you need a data set that contains spelling errors and where a human has annotated where the errors are and what are the corrections. What can we fine-tune LLMs on? What kind of tasks? We've seen the example of machine translation, spelling correction. It can also do question answering, spam detection, detecting if your mail is spam or not, sentiment analysis, detecting if a review of a movie is positive or negative, summarization, etc. It can be fine-tuned on any task that we have enough annotated data for. Now, one of the limitations of LLMs is that it requires a lot of data. It requires massive amounts of pre-training data to learn useful information about language, and it requires enough fine-tuning data to learn something about the task that you're actually interested in. Now, for many languages, we don't have enough data. And the result is that NLP tools are only available for a fraction of the world languages. And this will be the topic of the next video. What did we learn in this video? That NLP applications are powered by LLMs, that LLMs are neural networks which are trained to predict upcoming words, and they are then fine-tuned for specific applications, such as machine translation or spelling correction. And we saw that this process demands data.